Hi everyone. The purpose of this video is going to be to talk about transformations of exponential functions. Remember that a transformation of a function basically means that you no longer are just talking about the simplest version of the function. So we're no longer talking about the parent, but we're talking about how have I changed from the parent function. So when we look at exponential functions before we talk about the transformations, we are looking at something like this. It is very simple and it is just a number to the x. But we know that we aren't always going to see functions like that. We could have lots of other things going on. You could have a number multiplied out front times the base to the x plus 1 minus 3, right? That's just a super random example. But the point being that it's possible to add, subtract, multiply numbers, and those are going to have an impact on the graph of the function. So we're seeing the standard form of an exponential function right here in this box. Okay, this should look relatively familiar because it sort of has these same letters involved in it that you would have seen with transformations of other types of functions, including radicals, which we covered in the last topic. So first we're going to start with h and k, and that should look familiar. You're used to seeing the x minus h under the radical sign in a radical equation and the plus k after a radical sign in a radical equation. So they're sort of in similar places here if you think about it. Like x minus h, this part here, it used to be under the radical in a radical. Well, now it's in the exponent of an exponential function. The plus k was sort of just hanging out by itself at the end of a radical function. Same exact thing with an exponential. K is just a number that's added or subtracted on its own, separate from the exponential part of the function. So when we go through the impact these have, just like in our previous functions, H stands for the horizontal shift, or in other words, the horizontal translation. I know you guys know that I like that word if you have me as a teacher, but the horizontal shift. And if H is positive, that means that I shift right. And if H is negative, that means I shift left. Again, look at the form of this equation though. If I see x minus h as my exponent, what I'm looking at for a positive h value would be something like 2 to the x minus 1, right? If I plugged in positive 1 for h, I would have an exponent of x minus 1. So just be careful of that. So what I say right is if h is positive, but you're not going to see plus 1. You're going to see minus 1. So remember that it is opposite day in the exponent, just like it was opposite day under the radical sign. It is now opposite day in the exponent. So if you see x minus 1, you know you're moving to the right. If you see something that looks like this, where the exponent is a plus, you're going to be moving or translating to the left. Okay. So that is basically it for horizontal shift. So now let's talk about k, which is the vertical shift or the vertical translation. K is pretty straightforward. Positive k value shifts up and a negative k value shifts down. And there's nothing opposite about that. That's just whether you're saying plus a number at the end or minus a number at the end. So that's usually the one that people do not make as many mistakes on. The next thing I'm going to point out is A. A is a number that is being multiplied out in front of this whole equation, so before the base. So it says here if A is negative. So I'm just going to say that, write down this example. If A is just like a negative sign, and then you have your base to the x, that negative sign right there, right here, that negative sign is going to cause a reflection across the x-axis. Okay. And again, that is the same exact thing as we saw in a radical function. If you had a negative sign out in front, that was causing a reflection across the x-axis too. The other thing we're going to talk about is if a has a value that's not just like a negative sign, it's not just a negative 1, it has an actual value there. So let's say a is the number 4. So let's say we have 4 times 2 to the x. I'm hitting the dead spot on my screen again, common theme of these videos. But that says 4 times 2 to the x. Well, 2 right here, that is still my base because that is the number being raised to the exponent. So 2 to the x, like that is my exponent, but I also have a 4 out in front. And 4 represents the dilation. So whatever number is there, we say a dilation by a factor of that number. So in this case, the way I would write that would be a dilation by a factor of 4. Oh, that's supposed to be a 4. Again, dead spot on the screen. Yay, we got it. Okay. A dilation by a factor of 4. And again, a dilation just means either a stretch or compression. So basically, how fast is this graph increasing or decreasing? Like how steep is it? So we are going to go ahead and move on, and we are going to look at examples because examples help this make more sense. So the first part of the instructions say to identify the parent function. The reason that's happening here is because the parent function is not the same for every exponential function because the parent function is determined by the base. So for example, this first function was f of x equals 3 to the x plus 5. Since my base is 3, the most simple version of this function is f of x equals 3 to the x. So that is my parent. So my parent is literally, if you remember this from the beginning of the lesson, is just b to the x. So whatever the base is to the x power. So in this case, it is 3 to the x. When I go to look at my function, I'm going to look to see, is there anything else happening in this function? Well, the only other thing happening in this function is a plus 5 happening way out at the end. It's just sort of doing its thing on its own. And so if that is the case, that is essentially my k value or my vertical shift. And that tells me that I am translating 5 units up. And that's it for the first function. There's only one transformation occurring, so that makes it pretty simple. Now let's look at the next function. So here we have f of x equals 2 times 1/4 to the x minus 1. First step, I'm going to write my parent function. So remember that the parent function is just the base to whatever the exponent is. So remember the base is the number being raised to the exponent. So it's the number directly preceding the exponent. So some people are going to be tempted to multiply 2 times 1/4 and figure out the base, but that's not how this works because this 1/4 that's in parentheses here, that's the only number that's actually being raised to this exponent, right? So I can't actually just like go and decide that I want to combine this with like the 2. So what I'm doing, let me go reset, is just taking that base, again, that number right before the exponent, I'm rewriting that, and I'm just writing it to the x power this time, right? I'm not including any other information. It's just always the base to the x. And then when I go to identify transformations, I want to look at all the other things that are happening in this function. So basically everything that is not the 1/4 or the x. So here in the front, I'm multiplying by a 2. And then you can also see in the exponent, I am subtracting 1 from x. So when I go to write what these transformations are, remember 2 in the front, that was our a value. That causes the dilation. Okay, so that means that here my first translation is a dilation by a factor of 2. And then the other thing that's happening is up in the exponent, I have x minus 1. Okay, remember it is opposite day up in the exponent. So I see -1 and I think, oh, I should be moving left 1, but I have to do the opposite. So I'm actually going to be moving to the right 1 so that this function is going to be translated 1 unit to the right. Okay, and that does it for this page. We're going to do one more page of examples here in case you need it. I would urge you at this point to go ahead and pause this video and give these a try on your own. And then I'm going to go over it and you can come back and check your answers. I think that would be beneficial to you. If you don't think you're at that point, I guess you can keep watching, but I do highly recommend that you pause it and try this on your own. Okay, now going over this, again, we are starting by identifying the parent function. The parent function is just the base to the x, so my base here is 4/3, and so I just write 4/3 to the x. And then when it comes to my transformations, I like to just sort of underline in another color, but to point out all the other things that are going on aside from the 4/3 to the x. So we actually have 3 of them here. So we're going to have 3 transformations. So I'm just working through these one at a time, starting at the first one, which is that negative sign out in front. Remember that a negative sign out in front indicates a reflection over the x-axis. Then I'm looking at the exponent that says x plus 2. Okay, that's going to be a horizontal shift, opposite day in the exponent. So this is going to translate 2 units to the left. And then the last piece is that plus 7 out at the end. Remember, the number that's just sort of added or subtracted on its own, that is a vertical translation, and that just goes the way you naturally think about it. And so you are translating 7 units up. And that is it for that problem. Now for our last problem of this video, we are looking at number 4 here. And once again, I'm starting by writing my parent function. So my base here is 5. Remember, the base is always just the number right before the exponent. And so my base is 5. My exponent is x, because it's the parent, ignoring everything else so far. And then I'm going to go ahead and identify everything else that's happening. So there's a 1/2 out in front, there's an x minus 4, and then there is a minus 2. So I'm going to go ahead and write the transformations. I was going to put in another color because I thought that might help separate it, but I think it would look better in red. I don't really know. Hopefully it's not too much red for y'all to look at. Anyways, so there's a 1/2 out in front. A number being multiplied in the front is a dilation. So I would say a dilation by a factor of 1/2. Okay, then I'm looking at x minus 4. Again, this is moving me horizontally or left or right. And because it's in the exponent, I do the opposite of what I see. So this is going to be a translation. I'm just going to abbreviate that, of 4 units to the right. Again, it is right because I'm looking and I'm seeing minus 4 makes my brain naturally think left, but I have to think the opposite, so I'm going to be moving to the right. And then last but not least, that minus 2 at the end. Again, that is a vertical translation. And so in this case, because it is minus, we're going to be translating 2 units down. Okay, so hopefully that was helpful. If you have any questions, feel free to go back to the earlier explanation, or if you still have other questions, you can always ask me as well. But good luck with this concept.